So hello everybody, we are going to talk about our project today, which is named Descriptive Image Captioning by my colleague Ali Isa and me, Amr Abdul. Moving on to the baseline, to the problem statement. The basic idea is that we receive an image and we want to provide a textual description for it. So as you can see here, some of the sample inputs are basically images, and the sample outputs is, as we can see this in this picture, it's two young guys with shaggy hair looking at their hands while hanging out in the yard, and you get the idea for the rest of the images. We are just providing a textual description for each image. This is the baseline model. So we are going to move into the baseline model. It's basically, it contains an encoder and decoder, just like any image captioning basic model. The encoder is of ResNet 152 layers, CNN neural network. Also, it has a linear layer, and the decoder, it has embedding layers and long short-term memory, recurrent neural networks layers, and also linear layers. The dataset that was used in the baseline model is Microsoft Common Objects in Context, abbreviated as MS COCO. The baseline model received an input as an image and provided a caption for this image, basically. Moving on to the proposed updates to this baseline, we basically wanted to add the image descriptive to the whole idea of image captioning, where we are going to control the description of the image by adding a new input. Instead of just being an input of an image only, we are going to make it an input of an image and a temperature, where the temperature value is a value between 0 and 1, where the more the temperature value is, the bigger it is, the more description is given to the image, and the lower it is, the more details are ignored from the image caption. We're also willing to experiment with different encoders and decoders and see how this fine-tune the model. We're also going to do a form of data augmentation if needed, where the model, if the model overfits, we are going to mirror the image and enhance them. And we're also going to make caption variation for each image to support the idea of temperature. We are also going to try to enhance the accuracy of the model using different hyperparameters. We're fine-tuning the model overall. We're also going to use a different data set that supports different caption variations of different lenses. Now let's move on to what was actually implemented during this milestone. We successfully applied the base model with the pre-trained weights, used and tried it. We implemented a data loader for pre-processing the datasets and training the model. We loaded a new dataset named image description sequences, where every image has 5 sequences of description. We applied data augmentation to provide 5 variant description captions for each image with different lenses to support the idea of the temperature overall. We created a method to actually synthesize the temp value for each caption to estimate its descriptiveness and provide it as an input in training. We added the temp parameter to the decoder and the long short-term memory layers and implemented it in the training procedure. We trained the model on the image description sequences dataset, our new dataset. This is an example of this new dataset where we assume that the basic description of each image is basically the first sequence. Where here in this image, we assume that the very basic description of it is a small bathroom with gold trim around the shower door. And our application is the higher temperature goes, the more sequences are added to each other. And my colleague here, Ali, is going to explain the logic behind the temperature.
Okay, so for our methodology for training with the new temp parameter in mind, this of course has influenced our choice of the selected data set. So as we've seen, we have 5 different sequences of description for each image. The first one being the most important or the most basic one, describing the image. So therefore, we've decided to, based off of this, generate 5 different descriptions per image. The first one being just the first sequence, which is the most important sequence. And the second one being the first 2 sequences concatenated, the third one being the first 3 concatenated, and so on. Based on this description, we also generate an estimated temp value for this description, which is calculated based on the generated description over divided by the length of the longest description of the 5. We also ensure that the temp is a float value between 0 and 1. And then we append the temp value to the data loader so that it is provided with each training iteration and inputted through the decoder. Now moving on to our results after training, we see that here the temperature value does indeed affect the length of text. we see as the temperature value increased, we also see new information that wasn't in the previous output. Now we see that this is, of course, not the best behavior of the model, but we're happy to see that the temperature value does affect the length and the descriptiveness of the output. Now moving on to the evaluation metrics, we've calculated based off a sample of our data, a Bleia score of 0.107, which indicates underfitting. But this takes us to our next point, which is, of course, our proposed updates for the next milestone. So we, of course, will try to enhance the Bleia score through fine-tuning of the hyperparameters and possibly increasing the model complexity. Now we also might have to increase the vocabulary size because, as we've seen, the output contains many unknown tokens, so that could also help. Now we also might possibly try different encoders and decoders and adapting our models accordingly, just to try out different architectures to possibly enhance our model performance. And we also might perform data augmentation on other data sets to maybe provide to maybe have more options for data with more detail in the images, or data with more properly constructed description sentences of the images. Now here are our team member contributions. We must note that both of us have worked on deploying the model locally with the base model locally with the pre-trained weights, and also adapting our model to work on collabs for easier implementation and training procedures. Thank you for listening.